This is the solution to the first challenge problem. The first challenge problem was to prove that if b over a equals c over d, then the area of the region bounded by the curve between a and b is equal to the area of the region bounded by the curve between c and d. Okay, so first, divide the line segment from A0 to B0 into n equal segments. All right, so divide this line segment into n equal segments and use each of those little segments as a base to construct a rectangle having the height of the curve. So basically, okay, are you still recording? Yeah. So basically, yeah, this situation. All right, n for me is 5 in this picture, okay, because there's 5 little rectangles there. All right. Now the area of the kth rectangle would be this, okay? If we divide this into n equal segments, then the length of each segment would be n, and that would be the base, and the height would be of each little rectangle would be a plus k times that length, right? Okay, remember b minus a is the length of the segment, and if we divide the segments into n equal parts, then each part will be b minus a divided by n units, okay? And so the area of the kth rectangle would be this, right? That should be clear. Now we need to establish that this area is equal to this, okay? And how do we do that? Well, we use algebra. So let's see, if we multiply this out, b minus a times 1 and n minus this whole thing, we would get that. And then we can bring the terms with the a together, you know, an minus ka, right? And factor out the a, so then we get that. And then if we multiply the numerator and the denominator by 1 over a, we will finally get this, right? And this is the expression. Now, so we can express the area of the kth rectangle as this. We can do the exact same thing to find, okay, to find the area of the kth rectangle of similarly constructed rectangles between C and D. So if we do the exact same thing, if n is equal, if we use the same n and divide C and D also into n equal segments, then the area of the kth rectangle would be this. And similarly, the same way we did for the kth rectangles for the region between A and B, we can come up with this, and they're the same expression, right? So here's right. So here's one expression, here's the other, and notice that if b over a is equal to d over c, then these expressions are equal. So the area of the kth rectangle in each region is the same. The area of this rectangle and this rectangle are equal. The area of the second little rectangle and the second rectangle here, they are equal. Okay? So if for every k, a sub 1k and a sub 2k are equal, right? Then the summation of them must also be equal, no matter what n is. No matter what n is. So if n is arbitrary, then we can take the limit as n goes to infinity, and they will have the same areas. And that is the proof. End